Hello and welcome. My name is Vijay Chauhan and I'm Senior Director of Product Marketing at Cloudflare, and I'm really pleased to be joined by Arwa Jinwala, Senior Solutions Engineer. So Cloudflare is a global platform that helps make anything connected to the internet safer, faster, and more reliable. Now, in talking with customers around the globe, one of the most profound shifts that we've been hearing about is that legacy appliance-based approaches that customers have been using to secure their networks, they just aren't working anymore. And so we're here to help. Evolving your network for remote work opened it up to risks. Today, you will discover how delivering network security at the edge, not data centers, can better protect your applications, your data, and your users. Now, many enterprise networks look something like this. You have a headquarters, some data centers, and some branch offices distributed globally. All these locations are probably connected via various local MPLS providers and lease lines, all stitched together. Some of the branch offices and regional data centers might have broadband internet or local internet breakouts for connectivity. And even before we moved to a world where the workforce was working remotely, some number of employees, maybe contractors, certainly third parties, typically needed remote access to applications. They were probably VPNing in to a data center and then getting access to those applications via a VPN concentrator. Now, let's zoom into what the rest of the rack in a typical data center looks like. Now, at the data center, you typically have routers and switches, of course, and you might also have a string of other boxes, such as WAN optimization appliance, DDoS mitigation box, network firewall, VPN appliance, as we mentioned earlier, and a load balancer. And then you will have any number of application servers running in the data center as well. Now, each of these boxes were intended to satisfy the fundamental needs of enterprise connectivity, which is performance, reliability, and security. But let's zoom in further on the last box, right at the bottom of this stack of boxes. That's the application servers. Why should we look at those? Because the shifts that have taken place in application deployment, those are representative of the broader shifts in technology that has taken place. So let's have a look. How have applications evolved? A few years ago, when enterprise had to deploy application servers in their data center, you bought a server and you deployed the application on that server, and at most, you ran one application or one tier of that application on that one bare metal server. Skipping ahead to virtualization, you could now run multiple virtual machines or VMs on a single physical server. Now, you didn't need a different server for each application. But you still had a server, a metal box. How long did that take to deploy? Days or weeks. Generation 3, the public cloud vendors, specifically what we now call IaaS, or infrastructure as a service, they came along and they said, why do you even need to own the servers and the infrastructure at all? We have data centers and we will manage a series of VMs for you as a service. These were called machine instances. And like VMs and like physical servers before them, there was management overhead. But now you are officially in the cloud era. And how long does a machine instance take to deploy? Minutes or hours. So the shifts from servers to VMs to cloud instances and now to containers and serverless, this evolution has been inextricably tied to the speed and agility of deploying modern applications. And all through those transitions on the application side, what's been going on with the other boxes in the rack? Well, it turns out that while applications move to the cloud, network hardware has largely remained on premises. These boxes may have added incremental security and performance and reliability benefits, but they also contributed to massively increasing the complexity, the cost, technical debt, and just a insane web of dependencies in the data center. Fast forward to today, and those boxes are still around. You still have to rack and stack and configure and manage and upgrade them. They're aside from being OpEx intensive, they're also CapEx intensive. Those boxes may have worked for a while in the on-premises deployments and in the early days of the internet. But as applications and storage and compute has shifted, the network layer now needs to move also. And what about security, specifically network security, which is the topic of the session today? As application deployments have shifted to the cloud, trying to protect the castle using a moat has just become untenable. These appliances, these boxes were never quite designed for cloud applications. And so your network that probably used to look like this not so long ago now looks a little bit more like this. You have cloud applications in addition to on-prem servers. You also have remote workers trying to access those applications. No doubt, organizations will find themselves at different points in their transitions to the cloud. But regardless of where a company falls on this spectrum, we're all facing a common set of challenges. There is a complex, heterogeneous infrastructure environment which only exacerbates the fundamental problems of the internet more than ever. And the on-premise Band-Aid boxes that we once relied upon, sadly, they're just not designed to work in this environment anymore. And so as workloads have moved to the cloud, there really is no point in installing additional boxes on premises. Now, while compute and storage and applications have moved to the cloud, as I mentioned, the network layer has so far remained on premises, but organizations are reaching a breaking point. As the reliance of online businesses on the internet has increased, more so than ever during the pandemic, we've got the surge of remote work, we've got the increase in internet traffic. Many organizations are trying to deal with unmanageable network complexity and costs. And this is leading to a major architectural shift at the network layer and at the network security layer. It's well underway, and organizations are now looking at their other options. How can they have network security functions delivered from the cloud, which is where their applications have largely already moved to? And Cloudflare is leading this transition. The zeitgeist that we observed a few years ago of cloud adoption of storage and compute and application layers, it's now being followed by the network layer. We at Cloudflare have built a global cloud platform that delivers a broad range of network services to businesses of all sizes and in all geographies, making them more secure, enhancing the performance of their business-critical applications, and eliminating the cost and complexity of having to manage these individual pieces of network hardware. So what is Cloudflare's approach? What are we doing differently? Well, from our inception, we have been a software company. We believe in software defining everything. We are building network services that scale on demand, but you only pay for what you use. So you have predictable subscription-based billing, and you're always within milliseconds of all of your users worldwide. And there's zero latency for every service that you enable. And it turns out that this model works pretty well for network security as a service also. So whether it's a network firewall or intrusion detection, IDS-IPS, or distributed denial of service protection, DDoS, or zero trust, we offer all of these aspects of network security, but delivered as a service. In fact, these functions are built into our network. Now let's talk more about each of these network functions. To safely and reliably use the public internet as a critical part of your enterprise network, you need secure connectivity both with the public internet and between different locations. So step one is to move your network perimeter to the internet edge. Cloudflare accomplishes this with Magic Transit, which puts our global network between the public internet and your internal infrastructure in order to provide secure connectivity, but also traffic acceleration and DDoS protection. Cloudflare uses something called Anycast to advertise your company's public IP range from every data center in our network. When traffic hits one of our data centers, Magic Transit uses our vast threat intelligence to filter out network layer DDoS attacks in less than 3 seconds. Now, Magic Firewall, which is our firewalling as a service, can apply network firewall rules to further filter what traffic is allowed in. Now, a little bit more detail on how we do that. As you can see in this diagram, the Cloudflare edge data centers use BGP to announce the customer's routes to the world so that they can ingest all traffic that is directed to the customer's publicly addressable IP subnets. Once ingested by one of these edge data centers that is closest to the source of the traffic is then inspected for any threats. And all the clean traffic is then routed via a direct connect to the customer's data center, or it's encapsulated using GRE and tunneled over from the Cloudflare data center to the customer's network. Now, a word of caution. While cloud-based mitigation reduces the financial burden and it eliminates the maintenance headaches that come with on-prem hardware appliances, you've got to make sure you pick the right provider, because some providers can actually introduce a traffic latency problem. Most cloud DDoS mitigation providers have just a small set of distant data centers that are focused on scrubbing network traffic. Much of the time, these scrubbing centers are far from the organization's network, as well as far from the requesting client. This requires traffic to travel long distances before it's inspected for any threats, especially for users that are located globally or in more remote regions. Now, backhauling the traffic to a scrubbing center can add significant latency depending on the location relative to the destination server. This back and forth, it's called the trombone effect, and it often creates noticeable and painful delays. Now, often, the data centers that are dedicated to DDoS scrubbing inspect only for network layer, so layer 3 threats. So if you have any layer 7 processing that needs to take place, such as web application firewall inspection, so WAF inspection, or content caching, this is typically going to be processed in a different data center, which adds even further latency. Now, this problem is compounded when an organization uses individual separate cloud providers for the different networking and network security functions. So you might use provider A for DDoS mitigation, provider B for WAF inspection, provider C for CDN. When traffic must hop from one cloud provider to another, the latency can be measured in hundreds of milliseconds, which is very often unacceptable for most applications. Cloudflare is different. We don't rely on centralized, dedicated, distant scrubbing centers where you have to send your traffic for inspection. Cloudflare performs DDoS protection from every single server in every data center. This allows us to ingest customer traffic at a data center closest to the source of the traffic and mitigate attacks far away from the customer network in the cloud. And this is possible because Cloudflare operates one of the world's largest networks with data centers that are located in over 200 cities in 100 countries. Now, our network is also carrier agnostic. It's exceptionally well connected, and it is peer optimized. We run every service on every server in every rack, in every data center, in every city that we have a presence in. And this allows us to deliver the connectivity, the performance, the security, the reliability services at scale to our customers. It's this unified architecture that also gives us incredible flexibility in how we're able to use our vast capacity and provide resilience against the largest of attacks and network outages. It also means that we're incredibly fast. When you push new network security policies, as well as routing rules or serverless applications, they are deployed in a matter of seconds globally. So how is Cloudflare able to run every service on every server? Well, we built these services on commodity hardware, Linux servers to be specific. We use inter and intra data center load balancing using Anycast and ECMP to load balance traffic and ensure that no single server is overloaded. Now, once a packet hits a server, we use XDP, or Express Data Path, to analyze, to route, or to drop packets within the Linux kernel itself. And we do all of this at wire speed. This allows us to not only be independent of third-party vendors, but it allows us to innovate at scale, keep our costs down, and we're then able to pass on those cost savings from the economies of scale. Now, in addition to DDoS mitigation, why don't we talk about some of the other network security capabilities that we deliver as a service? Earlier, we mentioned Magic Firewall. Magic Firewall is our firewalling as a service. It allows you to craft powerful network layer firewall rules that will precisely allow you to allow or deny any traffic into or out of your network. We recognize in today's environments that network firewalling is no longer something that can just happen in a specific location or a couple of locations or even a set of locations. That just doesn't scale. Network firewalling needs to be baked into the network itself. And so at Cloudflare, we don't sell a firewall to customers. We're selling an edge network with firewalling built inside it already. This allows customers to set a firewall policy once through a single UI, and it's applied no matter the source or the destination across the customer's entire network. Now, organizations also want a unified control plane that's going to give you visibility into the incoming threats, access trends, traffic patterns, and we want to be able to do this without having to piece together signals from several different sources. And so our simple, intuitive, unified control plane is going to make it easy to provide that visibility, but also fine-grained control over what traffic is allowed in and out of a network. And it's all managed in the same pane of glass as all our other services, such as secure web gateway, DNS security, WAN tunnels, and routing controls, and more. Zero Trust is another key network security capability that Cloudflare delivers as a service. Zero Trust security means that users are no longer inherently trusted to connect to corporate resources based on simply being on the network. And unknown web code is not inherently trusted to run on an end user's device based on coming from a known site. Our platform will eliminate the complexity, it will increase visibility and reduce risk for every request and login that remote workers make to any resource. Now, while other vendors have zero trust network access and secure web gateway services, so ZTNA and SWG, they often host each of those services in different data centers around the world. With Cloudflare for Teams, our zero trust security solution, all of our security and performance features happen with one single pass, so it's incredibly fast for end users. You can allow or block DNS and HTTP requests according to your policy rules and keep employees from running into threats on the internet with a secure web gateway. But look, no secure web gateway can stop every attack. And so we add additional threat defenses by isolating remote users' browsing session in a secure container in the cloud. This protects their devices from unknown threats, and soon you will be able to implement even more browser-specific granular controls to stop data loss. Finally, we enforce zero trust application access to corporate applications, whether you rent or you own those applications yourselves. Now, instead of trusting users on the VPN or those that come from a specific IP address, zero trust application access lets you implement consistent identity and context-based policies for application access. And as with all of our services, Cloudflare's network is architected to deliver robust zero trust at scale. Now, to illustrate what network scale looks like, Cloudflare blocks 70 billion attacks a day, on average, across our network. Now, it's difficult to visualize a full day's worth of attacks, So here is a snapshot of just 30 minutes worth of attacks. You can see the huge volumetric attacks with high request volume in the big orange circles. These are the ones that make the headlines. But you also see there are very many low and slow attacks. These are the smaller circles that are on the rise. They have a lower request volume. They may not seem very large on this chart, but if that is your origin, if that's your network, it will hurt. The good news is that most of the intended recipients of these attacks, they never even knew that these attacks were happening. The Cloudflare network absorbed them and just took care of them. And our network is constantly learning. Each and every one of these 70 billion attacks daily actually strengthens our network security solutions. Our network is like this giant immune system that gets stronger with each attack. Now, before we see a demo of how this all fits together, I wanted to talk about a customer story. You most probably know Wikipedia. It is one of the most visited websites in the world with over 25 billion monthly page views. Wikimedia, the organization that hosts Wikipedia, experienced a massive DDoS attack in early September of 2019. Within a few hours, we got in touch with them and discovered that they were struggling to recover from persistent targeted attacks which had knocked Wikipedia offline. Cloudflare worked very closely with the Wikimedia team to help get Magic Transit in place. And once we were able to show results, the deployment was expanded to cover their entire site presence. Now I would love to hand over to Arwa, our senior solutions engineer and our resident expert of all things network security, to show what this all looks like in a quick demo. Over to you, Arwa.
Thank you, Vijay. Hello, everyone. Thanks for joining us today. I'm Arwa Jinwala. I'm a solutions engineer at Cloudflare. Today, we'll go through a demo on Magic Transit. We'll see some of the network analytics. We'll also see a demo on Magic Firewall, and we'll see a live denial of service attack being mitigated by Magic Transit. So let's get started. Let's start with Magic Transit. To protect your internet presence, you first need to be able to monitor and protect all traffic destined for your network. Magic Transit allows you to advertise your IP prefix behind Cloudflare. This gives you access to protection and monitoring from within Cloudflare. Let's take a look. First, you can see in the dashboard the IP prefixes we are advertising through Magic Transit. When we pivot into the network analytics dashboard, you can start to see the visibility we have into the traffic destined for our protected IP prefixes. First and foremost is the Cloudflare's DDoS mitigation statistics, protecting your network from network layer DDoS attacks. You then have an interactive map that you can filter to view statistics like packet volume and even top destinations. Going down, you have summary information regarding the types of attack Cloudflare has protected against and the details of those attacks. And finally, log data around all of the requests that have been seen, from geolocation to source IP and even ASN. You can see there is a lot of information that can help you monitor and protect your internet presence. Now let's see Magic Transit in action. We are going to switch over to a testing endpoint. You can see where the endpoint is located based on its external IP. Now we are going to kick off a denial of service attack from this endpoint against our protected network in the background. Switching back to our network analytics dashboard, let's change the filter to show you live statistics. And there it is. We can see that Cloudflare has started to mitigate the new attack we just started. If we move down and filter on the source IP for the attack, we can see it matches our testing endpoint and you can see the corresponding spike in the volume of packets. Moving further down, we can get some more details about the attack. We can clearly see that it is in fact a UDP flood, and if we expand the activity log, we have lots of information about this UDP flood. We see the destination IPs it is attempting to attack and the port. We also see the volume of the data and packets as well as start and end times of this specific attack. The dashboard will also show us originating geolocation as well as ASN. The DDoS protection you saw is a default broad protection for your entire network. For more granular and precise security controls, we can actually go into the Magic Firewall. Magic Firewall can be accessed straight from the analytics dashboard to write some rules to stop traffic outright. Since we already have a filter on our attacker's source IP, we can actually just press the Create Magic Firewall Rule button and it will bring us into the Rule Create wizard, with our filter already populating the rule. Moving around the rule creation page, you can see all the different parameters we can match on. What I'm going to do here is add a port to this rule as well. Since our attack came on UDP 5500, I'm going to add it to this rule. To sanity check our rule, you can see that we write out the rule in a common format like Wireshark, so you know that you will be matching on the right kind of traffic. Once we save the rule, you can see it shows up in our rule set, and once traffic starts matching on that rule, you will see the counters increment. Now that we have protected your network, we need to ensure that the legitimate traffic is able to reach our data centers. This is done through GRE tunnels from your data centers to the Cloudflare edge. In the tunnel health dashboard, you can see all of our data centers and the health of the established tunnels. Cloudflare's network can act as a hub for all your traffic from the internet and between branches and data centers. To learn more about how this works, join us for the WAN as a Service session later this week. With that, we conclude the demo, and back to you, Vijay.
Thank you, Arwa. So just to wrap up, our network architecture, which serves as the foundation for all the services we deliver, that's what differentiates us. Our distributed network architecture, it allows us to deliver network security as a service from every one of the 200 cities that we have a presence in. And it gives us a network capacity of 67 terabits per second and growing. And all of this comes with built-in network security functionality such as network firewalling, DDoS mitigation, and zero trust security. Everything we build at Cloudflare, we build with performance and security in mind. So when Wikimedia or a financial trading application deploys Magic Transit, for example, they will not only be secure against attacks, but the performance will be lightning fast. And every product we build at Cloudflare is built for customers of any size and any technical sophistication. We aim to build easy-to-use, intuitive products that solve complex problems for our customers where your deployment time is not days or weeks, but often hours or even minutes. We also don't charge for attack traffic, and we were the first in the industry to introduce unmetered and unlimited DDoS protection. And all our products are built in-house on our own servers, which means we're not dependent on third-party vendors. We can deploy patches to do firmware upgrades, leveraging the learnings from our own vast network really, really quickly. We're a company that's known for our innovation, and building software on commodity hardware actually helps us to innovate really quickly and even keep our costs down and then pass on those savings to our customers. Finally, our network is like this immune system for the internet. Our threat intelligence is harnessed from the data that is fed into our systems from nearly 25 million internet properties that Cloudflare protects today. Our systems are constantly learning, and so an attack against one customer is used to learn and protect against similar attacks against any customer. The public internet is becoming the new corporate network. That shift calls for a radical reimagining of network security and connectivity. We are honored to be a trusted partner to companies like yours in this journey. We look forward to hearing from you about your journey and continuing to build these solutions together. Check out these resources to learn more. Awesome. And so that brings us to the end of the presentation. we have a few moments to take some questions. Please do use the platform to submit any questions that you have. I see that some questions have been trickling in as we've been presenting, so I'll get us started. Okay, so one here is, what inspection engine is Cloudflare using? So what is the inspection engine that we're using? And so the answer to that is that it's actually a homegrown solution, and it's a combination of several inspection engines. Those three DDoS mitigation systems in particular are DOSD, Gatebot, and FlowTrackD, which you can read and learn more about in our blogs and also in our developer docs. DOSD, just to summarize, is a decentralized system. It runs autonomously in each of the Cloudflare servers in every data center around the world, and it will analyze the traffic and apply local mitigation rules when needed. Gatebot is more of a centralized system. It runs in Cloudflare's core data centers. It detects and mitigates globally distributed volumetric DDoS attacks. And then FlowTrackD is Cloudflare's TCP state tracking machine, and it works using the ingress traffic that routes through Cloudflare, and it helps you to identify the state of the TCP connections. Let's see, what else do we have? I'd love to see more on the Magic Firewall dashboard. Hopefully you got to see some of that in the demo that Arwa just showed a moment ago. Let's see. We are considering transitioning our network security to the equivalent offerings from public cloud vendors. The alternative is virtualized appliances from existing hardware vendors. These can also be deployed in our public clouds. Which direction should we go? Okay, so I think there's a little bit to unpack there. But if I understand the question, I think what you're talking about is leveraging the public cloud vendors' native network security offerings. So for example, AWS or GCP have their own network firewalls versus using a hardware vendor's virtualized offering. So a hardware vendor that already offers network security products, but in a virtualized form factor. And that can then be run in public cloud. So, a good example of that, I'm assuming, is like running Palo Alto networks or a Checkpoint virtualized next-gen firewall in AWS. We'll probably go in a few directions, but I think the first thing to note is that those two options might actually end up collapsing into just one option, depending on what your environment looks like. The public cloud network security offerings are typically centered around something that they call VPCs, or virtual private clouds. And so the network security rules that you get through the public cloud vendor, such as firewall rules, those are going to be all about protecting and controlling access to and from your VPCs. So if the only infrastructure that you have, your workloads, your applications, if everything resides in your VPCs in that one public cloud vendor, let's call them, public cloud vendor number one, then great. Then I would say you should totally use the native network security offering from that public cloud vendor number one. I think the reality, however, is that most customers have at least some heterogeneity in their infrastructure. Either they have some on-prem workloads and applications, or they have workloads and applications in a second or even a third public cloud. And so any traffic that does not ingress or egress the VPCs of public cloud provider number one, that traffic cannot be controlled by the network security service that is provided by public cloud provider number one. It's a bit difficult to explain without showing you a diagram. Hopefully you're following along. Now, in that scenario, you may decide to actually complement public cloud provider number one's service with a hardware vendor's virtualized appliance for all the non-VPC traffic. That's going to add complexity. Even without me drawing the diagram, I think you can see that's going to add complexity and cost, not reduce it. Now, if we do indeed treat those two options, so network security services provided by a public cloud vendor and those provided by a hardware vendor in a virtualized form factor, if we do treat those as distinct options, you might think that you're successfully transitioning to the cloud and that you're getting network security as a service. But some of the legacy drawbacks that I was talking about with on-prem appliances, some of those still remain. Cost-wise, sure, you no longer pay CapEx, but there is still a very similar OpEx overhead. And then from a complexity perspective, it's likely that you are either maintaining or making the complexity worse because all you've done is you've moved your choke point from one part of your infrastructure to another part of your infrastructure. And you may actually end up performing some unnatural acts, which networking people typically call traffic backhauling or hairpinning. And this is where you're taking your traffic from other environments and forcibly bringing them to your public cloud, the public cloud vendor number one, for example, just so that you can inspect that traffic. I'd be remiss if I didn't mention that there is another option, which we talked about in this session, and that's the Cloudflare approach, which is quite different. We don't send the traffic somewhere else to be inspected. It's inspected effectively in transit, as close as possible to the source of the traffic, on its natural or on its accelerated route from source to destination, wherever that source and destination might be. Okay, let's see. Arwa, do you want to take this this one about the operating model and best-in-class technologies?
Yes, absolutely. So it's on similar lines like the previous question. So our operating model is to buy best in class. It's unlikely that Cloudflare or any other vendor would be best in class across all network security services. Why would we sacrifice protection over having to work with a few more vendors that offer best in class? Great question. I'd say think about all the network security services you want. So whether it is DDoS, firewalling, IDS, IPS, zero trust, etc., etc. You could end up with separate cloud vendors for each. And each of those vendors, when you try to stitch them together, could actually introduce more risk at the seams. Not to mention the impact on security teams who have to work across multiple tools, multiple UI, and hope that their multiple policies, when implemented, are going to deliver a consistent security posture. Aside from introduction to risk, when you have multiple vendors stitched together, there are probably other key decision criteria you should think about. You know, there is latency, there's support, as well as cost. So in an on-prem world, latency and support weren't really an issue. Your packet took microseconds to go from one box in your rack to another. But now if you use, say, Cloudflare for DDoS mitigation and another vendor for, say, CDN or WAF, your packet has to travel from one cloud to another. And that adds latency. Also, previously in your on-premises rack, when you had to troubleshoot something, it was easy. You'd unplug one box and another and see where the issue was. You can't do that with cloud. So it's easier for customers to deal with one cloud provider for all their network and network security needs. And cost-wise, you can imagine, cloud providers are incentivized for passing savings to you if you use them with multiple services.
Awesome, Arwa. Let's see. There's a really short question. Does that service require Argo? So just a little bit of background on what is Argo. So Argo Smart Routing is Cloudflare's traffic acceleration product, and it sends any traffic from point A to point B anywhere on the planet over the fastest and the most reliable routes. Today, we do have Argo available for HTTP and TCP traffic, and very soon we will have the same essentially traffic acceleration service extended to all IP traffic. And yes, that will natively integrate with Magic Transit if indeed Magic Transit was the service that you were referring to. Another question here: do you support site-to-site VPN connections? Also, do you support site-to-site VPN connections also, so we can build those into the cloud instead of running them connected direct to our local sites? Yes, the answer is yes. We didn't speak about it very much in this session. There's actually another session that you should tune into around Magic WAN. Magic WAN, a wide area network, is our corporate WAN connectivity solution. So it's precisely meant for site-to-site connectivity, and it allows enterprises to connect their headquarters, their data centers, branch offices, even remote workers and devices, regardless of location. And you're able to do this all very securely over the same Cloudflare network that we've been talking about. And you're going to do that either via the GRE tunnels that I mentioned earlier, which are leveraged as part of the Magic Transit solution, or through direct connections. And we also have direct connectivity, which kind of answers one of the other questions that somebody had about public cloud hosted providers. We have direct connections into public cloud providers also. And very soon we will have IPsec VPN tunnels as well. So definitely recommend watching the Magic WAN session, which is going to be hosted by my colleague Annika Garbers. Let's see, maybe we take, I think we've got time maybe to take, Arvo, do you want to take one more around the cost savings?
Yes. What kind of cost savings can we expect with Cloudflare? So I think the answer is it depends. But if I were to give you, say, a recent anecdote, one of our customers is saving around $100,000 per year just by using our DDoS mitigations. That comes down to the way we've been able to reduce costs and pass those savings to you. And it turns out we are able to help customers of all sizes reduce their IT infrastructure bills while increasing their operational agility. I would highly recommend taking a look at our website to see some of our public case studies for more concrete examples of those cost savings.
Awesome. Maybe I will take another one. Our peers are experiencing DDoS. It's difficult to establish how seriously to take the threat because it's free to send a ransom note. How can Cloudflare help in the event my organization is threatened? So I guess first thing is DDoS. I assume you're referring to ransom DDoS, which is that's a type of attack where the adversary, the malicious party, is, as with all ransomware or ransom DDoS, they're trying to extort money from your organization by threatening you with something. And in this case, the threat is distributed denial of service attack. And I think the unfortunate reality is that any network infrastructure, any asset which is exposed to the internet, which these days is a pretty broad, a pretty large attack surface. Anything that's exposed to the internet, it's only a matter of time before you are either threatened or you're actually attacked. And so if you've not seen one of these ransom DDoS notes before, you should have. They definitely make for interesting reading. The TLDR of what those notes say is pay this ransom typically within 7 days in Bitcoin, or we will knock your site, so your websites or your web presence, or your entire network offline. And every day that you don't pay the ransom, the ransom goes up. Now, in some cases, the attacker, the question mentioned that it's free to send a note, but in many cases, the attacker is actually going to carry out a small demonstration attack just to illustrate that they do mean business. But actually, even that illustration, that demonstration can also be fairly inexpensive. Cloudflare has successfully mitigated the biggest of these attacks. For our customers, we've done this through our DDoS solution that I've been speaking about earlier, which is Magic Transit. Just kind of word of recommendation, if you or your organization do get a ransom note, first thing is don't panic, don't pay the ransom. Paying the ransom, as you can imagine, only encourages bad actors. And there's no guarantees that you won't be attacked and that your network won't be attacked now or later. Obviously, notify local law enforcement, and they are most likely going to request a copy of that ransom note that you received. And of course, if we can be helpful to you or your organization, we're standing ready to help. Awesome. I think with that, we will bring our session to a close. Thank you, Arwa, for presenting today and for the demo and for helping out with the questions. And thank you so much to the audience for tuning in. We look forward to meeting with many of you in the coming months. Thank you.
Thank you, Vijay. Thank you, everyone.